assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
In this example, we're given that the magnetic flux through a single coil of our 12 coil wire here changes from 9 Webers to 4 Webers in a time period of 0.05 seconds. And because of this change in flux, there is an induced EMF, and similarly, there is a induced current because of that induced EMF. And what we want to figure out is, given that we know what current gets induced, we want to find the resistance of our wire. All right. So if we recall that Faraday's law of induction states that the induced EMF is just going to be equal to the change in flux through our loop over the change in time. So our flux, our change in flux, can be written out as the final flux minus the initial flux, where our final flux is just going to be 4 Webers for a single loop. So for n loops, it's going to be n times 4 Webers. And similarly, for our initial flux, for a single loop, it would be 9 Webers. So for n loops, it will be 9 times n Webers. Okay, so if we plug those in, we'll get that our change in flux is equal to 4 times n minus 9 times n, or, since these are like terms, 4 minus 9 is just 5, so minus 5 Webers times n is our change in flux for all of our loops. So if we plug that in, we'll have that our induced EMF is going to be minus 5 Webers times n, which is just going to be 5 Webers times n divided by delta t, where delta t in our case is 0.05 seconds and n is 12. So if we plug those numbers in, we'll be able to calculate our induced EMF. And our induced EMF will have a value of 1200 volts. Now, to determine the resistance from knowing this induced EMF and our induced current, we can recall that Ohm's law states that the voltage drop across a resistor is V equals IR. Or, in this case, our voltage is just going to be our induced EMF here. So we'll have E equals IR. Or, if we divide both sides of this equation by I, we'll have R equals E over I. Where E is 1200 volts and I is 230 amps. So if we divide those two numbers, it's going to come out to be 5.22 ohms. So we just calculated the resistance of our 12 loops of wire here by determining what the induced EMF was in our loop given this changing magnetic field, and then using that induced EMF and our current to calculate the resistance.